Thank you for Disk Systems for organizing this, and thank you for Czech TV for hosting us here. Welcome. My name is Mihkel Maemets, so I'm a senior sales engineer at Haivision. I've been there close to 5 years. I've had the privilege of working with projects all around Europe, in Scandinavia, in Spain, in Eastern Europe. So it's always nice to see the differences in workflows, the differences in budgets, and the differences how people are using our technologies and where we can provide some value into that. As Peter mentioned, we have a video greeting from Haivision's chief strategy officer, that is also one of the inventors of SRT. So I'll show you that first, and then we'll get started.
Zdravím Prahu. My CEO Miroslav would be happy that I introed with that. He is a true Czech Slovak. So welcome everybody, and thanks for coming today. My name is Peter Mogg. I'm Chief Strategy Officer here at Haivision, and I'm actually also the inventor of SRT. It was my idea, and I brought it forward within the company and drove the open source adoption of the protocol. Many people actually used to ask me, how much does SRT cost? Now everybody realizes that SRT is open source, it's free to use under Mozilla Public License, but what they really want to know from me is actually, why did Haivision do it, and how does Haivision benefit? And that's what I'm here to kind of get to today. Now first, a little bit about the background of where SRT came from. I believe it was back in 2014 or something at IBC. Many broadcasters came to me, and they were saying, satellite and MPLS, I mean, they're effective at video contribution, but they're expensive and they're difficult to provision, highly predictable, but very, very difficult to instantiate. And they said, the internet is actually becoming quite effective, and bandwidth is becoming readily available. How can we transport video securely and reliably over internet connections? And they said, Haivision has a lot of technology in its portfolio. And I thought, if we provided just a simple package that you put at either end of a video workflow that incorporated our error correction technology, that incorporated our encryption, we could actually provide a package that transports video over the internet. And that's really where SRT was born. And quickly, I believe in 2014, we launched SRT within the Makito encoders, and allowed companies the ability to get satellite MPLS type performance over very easy to use and readily available internet connections. After that, we brought to market the SRT Gateway, a great relay product, as it were, that was a protocol flipper and can act as a central point for SRT stream distribution. And then we also brought out one of my favorite products, which is Play Pro. Play Pro is a mobile app freely available for iOS and Android that is a really effective SRT stream player, stream catcher. So from then, we became very famous for having these solutions, but the market actually kind of spoke to me, and many friends came to me in the market and said, Peter, if you don't get SRT beyond Haivision, it's actually going to die, and other people will adopt different technologies. So, I started thinking about, different ways to license it into the market. And then one day somebody came to me and said, Peter, it's going to be a race to the bottom. Why don't you just lead the market rather than follow and open source the technology? So in April 2017, at NAB in Las Vegas, just before the show opened, we announced the availability of SRT on GitHub. We had it packaged up beautifully and highly consumable, and that's where SRT was actually born. Actually, within 3 or 4 hours, this competitor of Haivision actually had SRT in beta on their decoder. That's how easy it was for companies to get into the SRT game, so to speak. After that, the adoption was like wildfire. Within the very first year, great companies like Eurovision and Harmonic had endorsed SRT. In following years, we had, Telestream and all of the broadcast companies and Sony endorsed SRT, and then the cloud companies started jumping on board, and Microsoft was an early supporter of SRT. Ultimately, Amazon AWS, YouTube, Google, everybody jumped in and started supporting SRT. Today, over 700 companies have publicly joined the SRT Alliance and shown their support for the SRT protocol. Now, as it's a technical audience, I just want to be very clear. SRT doesn't encode video, but it provides great intelligence for transporting the video. SRT not only detects packet loss and network performance, but also the bandwidth. And companies can actually use the APIs of the SRT technology stack and tie them straight to the performance of their encoders. And that's what actually Haivision has done on the Makitos, where we have tied the detection of the available bandwidth directly to the encoding engine, so we can deliver network adaptive encoding, what we call NAE, which allows the encoder to adjust its bit rate dynamically based on the network bandwidth availability. So that's kind of the story of SRT, where it came from. And today, nothing makes me more proud than to visit a client like, ESPN. And I was at a conference a few weeks ago, and they said they have over 70,000 independent SRT streams running every year. Massive broadcasters have their entire infrastructure today relying on SRT. So I want to leave you with that and thank Bogdan for having everybody in the room today, and our partners for showing you some of the SRT solutions and teaching you a little bit about the dynamics of how to use SRT. And I hope to be in Prague in the near future, perhaps when it's a little bit warmer. It's not warm here in Montreal, but I hope you have a great day and enjoy this conference with our team. Thank you, and ciao.
Yeah, so that was a bit of a small greeting from Haivision headquarters. So I'll just give you a quick overview on Haivision as well. So Haivision is headquartered in Montreal, Canada, but we have offices and development facilities all over the world. We have a large presence also in France after we purchased Abbey West. So here's actually a bit of a timeline of Haivision's development and which companies and technologies we have implemented and acquired. So for me, the big milestone is, of course, Abbey West, Paris Olympics. We had a huge presence there as well. Open source of SRT is, here, 2013, 14, something like that. Who paid attention? Oh, and just some numbers on that. So I'd say we are a relatively small company. We try to be, and try to listen to the market, what the customers need, and try to answer to that. And yeah, and we have 4 Emmy awards as well. So 2 for the SRT protocol, and actually 2 for the SST protocol as well. We are structured in 2 parts. One is the traditional broadcast side, and the other is basically mission, which covers defense, enterprise, all that. And from revenues perspective, actually, broadcast is 1/3, and mission is 2/3 on that. So it's we have quite a lot of business outside of broadcast as well. Some notable logos you might recognize, some of them, or all of them. And some broadcast logos as well. One thing I'd like to highlight, we've run, a number of years, we've run our broadcast report, where we've asked the industry about the adoption of SRT, the usage of different protocols. But for me, we've had this question a few years now in the questionnaire. And what we are seeing more and more is that broadcast organizations, that biggest challenges basically are budgets. Budgets are staying the same. You need to do more with the same budgets, or they are going down. And then the same is qualified staff. So this is, and we are trying to answer to these questions as well. So interested to hear also your feedback on how do you see this. So a bit on the agenda, how I would like to split this. So I plan to first just start on the theoretical side, on the SRT protocol, what it does, how it works, what it is and what it isn't as well. I'll show you some demos as well, so this wouldn't be too boring. I'll try to make it a bit more interactive. Also a few words about SST protocol, which is our bonded protocol as well. And then on the second section, to discuss more on how SRT is implemented in different products and hardwares and softwares. And I'm using then our product ecosystem as examples. And on this, I'll do some more demos as well. And then the last section is more about different type of use cases, also customer case studies. So this is more or less the plan. So first of all, questions to you to warm up. So who is familiar with SRT? Okay, no, that's a good coverage. And who is using SRT? Okay, well, really good. And which solutions are you using SRT? What are you doing with SRT? Contribution, okay. Something else? Okay. Are you using any Haivision solutions? Which one? Play Pro? Okay, excellent. Yeah, I plan to use Play Pro here as well. So then it's more fun. Good. So just a general note. If you have a question, shout it out. I like it if this is more interactive, and then we can have a discussion, or you can help me steer these presentations. And I'll be using some live demos as well here. Most of my equipment is at home, or it's cloud instances. I came here quite late. So good. Okay, so this is first one. Let's begin with the actual stuff. So before we start with SRT, we have to understand a bit on where we have come from. So we all know about SDI, coax, fibers. It's all predictable. You plug in a cable, you either get a signal or you don't. And it's easy to troubleshoot, well, most of the time. Predictable. And what did we use before then to actually get remote contributions? Was it something like this? Yeah? Okay. So, and you all know the cost of running an DSNG truck. You have to have the frequencies. You need to schedule it, and all the hassle to it. And for me, coming from Northern Europe, there's always the additional problems that the Earth is round. So it's difficult to point it to the to the satellites sometimes, as well. And not even talking about snow. So let's not go there. So of course, let's use IP. Let's use public internet, and everything will be nice and simple, right? Is it always simple? So there are additional not issues, things to solve, I would say, with all IP transmissions here. So when we are doing a broadcast, what would be the criteria that we care about? So, of course, latency, yeah. With satellite, we know. So, what would be a typical latency for satellite uplink, downlink? Okay, yeah, I guess so. Yeah, so it's quite a long latency with the satellite. Also, what's the content quality? Oh, my ordering is a bit strange, but okay. And yeah, what are we actually sending? Are the decoders able to decode it? What about encryption? And audio tracks? Oh. So, yeah. So, would you agree that these are the things that we care about? That these are important when we are doing a live transmission? Yeah. Okay. Okay. So, when we talk about IP transmissions, we come to TCP protocol. We come to UDP protocol. Which streaming protocols use TCP? Can you give me examples? Yes? RTMP, yes? Yeah. Good. So just as, to explain the fundamental difference between TCP and UDP. With TCP, whenever you're sending a packet, you need to get an acknowledgement that, okay, I've received this packet now. And then after that, I will send the next packet. With UDP, there is no built-in acknowledgement on that. UDP is just, okay, it's sending, it's sending, it's sending. So later on, I'll show how then SRT solved this issue on this. So with TCP, I'll later show we have some issues when the distances grow longer, for example. So yeah, and okay, so an example of what protocols we had or have. So RTMP, that's TCP-based, HLS, that's HTTP, that's TCP-based. And then on the other side, we have TS-UDP or RDP there. So what causes then packet loss in the networks? So here is some examples on that, and then the percentages of the packet loss that we might see there. And what does packet loss then do? So you've probably seen this example like a zillion times. But yeah, so if we send a regular UDP transmission and we have packet loss, okay, we see it straight away in the output. So because there is no packet recovery in this sense. So using just UDP over internet, so I guess that's not the most workable idea. So previously, I would say that was the reason we had the managed networks, MPLS links to transmit, to have a more stable network between points. Another example is with RTMP. So because RTMP, it's TCP based, it also means that, like I showed you in the previous slide, that each packet we send, we wait for an acknowledgement. Then we send the next one, which means that the longer the distance grows, the longer the round trip time becomes with that. And at some point, we are not even able to send the RTMP feed through, because just the distances are too long and all the data is not getting through there. So here are some examples with different bit rates on that. And you probably remember with the RTMP and distribution workflows why we had all of these CDN infrastructure. We had the ingest points all over the place, that we would be as close to the source as possible on this. So yeah, so with RTMP we have limitations on this. So just a bit of a overview comparing these different criterias and how they match then with UDP or TCP. So clearly the content quality is better. We have lower latency. Here it's more predictable. With security, it's okay. TCP might be better on that. So just as a bit of an overview. So okay, this was just as a background before we got, ta-da! We got the SRT. So this is actually a cardboard sketch of how the SRT mechanism was sketched out. It's and it's framed at Peter Marg's office in Montreal. So I find it quite funny how these things. It starts really simple in the end. So, what does SRT stand for? So, this is the official one, the secure, reliable transport. Dushan, do you have another? Yeah, satellite replacement technology. That's we use that as an internal joke, but in the end, it's not a joke. It's already a reality. What we are seeing, that it is replacing satellite links almost anywhere. So. So yeah, so basically, yeah, first one, yeah, just replacing satellite links. Second, also replacing RTMP quite a bit. And then it's a huge help in also cloud workflows, I would say. Like even with YouTube, you are able to ingest SRT into it now, with some limitations, but yeah, it's so bit of an overview. What are the different things what SRT provides? So first, it's low latency. We are able to control the latency. And it's more or less deterministic, unlike with RTMP protocols. Then, of course, we have quality issues. We have error recovery. We are able to get the content across without any issues. And it's totally content agnostic as well. It's SRT doesn't care what do you put inside SRT. I have another slide later on top. And then it supports encryption as well. And then also the point about firewall traversal. So it's really simple on that. Of course, I'll show later, but basically we have our callers, listeners, and SRT requires a single UDP port to be open on either side of the connection. And that's it. So it's, I would say it's relatively simple. A bit on what can we actually configure. We can configure the latency buffer. We can configure the bandwidth overhead or headroom. Yeah, overhead is better, I would say. I'll explain it in more detail. Then, are we using encryption or not? And then, is it what's the actual SRT mode? So, okay, is it the caller, is it the listener? There's also rendezvous, but I don't want to get into rendezvous. I don't think it's that relevant for professional workflows. Let's leave it at that. So basically, in SRT, we have a transmission buffer. So on both sides. But instead of talking about the transmission buffer in kilobytes or megabytes or whatever, in SRT protocol, it was decided that we talk about milliseconds. And basically, we talk about the latency on that. Of course, in the background, it translates that, okay, it's 100 megabytes of memory or whatever, of course. But just to make it more user-friendly, it was decided that it's better to define it in time in this. So basically, I think this slide explains everything with SRT now. So we have our encoder, we have a decoder. There's an SRT link over it. The encoder, it has its send buffer that is defined by the latency time we have set. Okay? So then the encoder starts to send its packets across to the decoder. The decoder is filling up its receive buffer. So here, like we see that packets 8 and 9, those are in transit. And then, if we are missing some packets, we have an automatic re-request mechanism. So instead of sending an acknowledgement on each packet that we received, we turn it around. We are basically sending a non-acknowledgement that, hey, I'm missing packets 265, send it again. So this is the mechanism that we are able to recover the packets that we haven't received. And then, of course, the sending buffer, it receives the non-acknowledgement, it retransmits those missing packets. And in the end, we have all the packets we need to proceed and start to decode the video. So this is basically how SRT works on this. So what do we need to do so okay, we are missing some packets. Let's say we have a connection of 10 megabits. If our bandwidth is already 9 megabits, then we have an overhead of only 1 megabit. So if some packets are missing, so then we have only that 1 megabit to resend the additional packets. So that's why it's really important also that when you have your link, to have enough overhead that you are able to resend the missing content in that, because we need to keep sending the actual feed, and then on top of that we need to send the missing packets as well. And if we don't have enough overhead, or our link is not big enough, then we just saturate the link, saturate the connection, and we are not able to do that. Was it clear? Was it too confusing? Okay, yeah. Okay, so what is the optimal latency? Here we come into something called RTT. RTT is round trip time. It's ping times 2, I would say. That's the easiest way to do to explain it. So here's an example. Our ping is 85, our RTT is double of that, 170. So usual recommendation is that it's RTT value times 3 or 4, that you use that as your SRT latency setting. So this is an example that between London and Montreal, with an RTT of 170, we should be using SRT latency of 510 milliseconds. If the packet loss is higher, we should be increasing it. We should be using times 4 in this case. So this is all documented on our website. So here's an example on that. Just to give you a bit of a, give you an idea, reference numbers, something on this. Yeah, okay. Okay. SRT in itself, I would say it's only a wrapper. It only encapsulates the content, and it doesn't care what's inside. It doesn't even have to be video. It doesn't have to be broadcast content. It can be basically anything. So here we come into the question of, I would say, the problem we've had in broadcasting is interoperability between different manufacturers' encoders with different manufacturers' decoders. So, and I would say that SRT, it doesn't change that in any way. We still have to check that and verify that, okay, we have a feed coming from a Makito. How well does it decode on a harmonic or a TEM or the other way around? Or you get some random feed from wherever, yeah, a mobile app. Okay, even if it's wrapped in SRT, inside it's MPEG-TS. So how well does it decode with the, whatever you are using to decode it? So it doesn't really change that age-old broadcasting problem in that sense. So I would say that it's both a good thing and a bad thing. It's like that, or in a way, it has nothing to do with SRT. There. Okay, a few words about encryption. So in SRT, we are able to encrypt the content. So basically, we can use symmetrical keys. So basically, the same password, the same key is used both for the encoder side and the decoder side, or the sender and the receiver side. If the receiver or the decoder, if it doesn't have the key, it's not able to receive it. It's not able to decode the feed. And we are using AES encryption for this. Yeah, we have the key, and same key here, and then it's unlocked. Yeah, wonderful. So now the connection modes, I mentioned it briefly already. So if we have an encoder and decoder, so in this case we have an encoder that is the caller. So in the decoder we have to be the listener, but it doesn't, and then we're able to send the feed. But it can be also the other way around. So we can have a decoder that is the caller, and we can have an encoder that is a listener. So the decoder is initializing the SRT connection to the encoder. So, and still the video stream will go from the encoder to the decoder in that case. So this is also really important, that encoder doesn't have to be always the caller. It can also be a listener. So it gives much more flexibility in setting up the workflows. So another example is here that, okay, we have an encoder somewhere. We have a decoder also somewhere, totally different random place. How are we able to connect them? We have no control over the firewalls in the networks where these devices are. So, okay, one way, we can use a relay. We can use an SRT gateway that is relaying the feed through it. So basically, both sides here will be then callers, and then SRT gateway will be the listener. It has input that is listener, and it has an output that is listener. So we are able to do this type of relay workflows as well. So, and then we only need to make sure that our gateway has 2 UDP ports that are open to accept the connections. But this can be a cloud instance, wherever, or totally third-party place. So again, much more flexibility on this. Few words on the actual what's needed on the firewall or the router that we are able to send and to receive the SRT connection. So as I said, this is like the case I'm using at home. I have port forwarding, I have network, I have nothing enabled there, and I'm just forwarding some ports into my internal network. That, okay, UDP port 10,000, point that to my device in the internal network. So, but this has to be done. It's still, there has to be a rule in the firewall that it allows this traffic to come in and also then to go out as well.
Can I have a question?
Yeah.
How is differences between compatibility of version SRT and handshake?
It always takes the oldest version. So there's a version check during the handshake, and then both sides will use that one that is the oldest. That, okay, if one side is 1.3, the other is 1.54, then they both use 1.3. So that they are backwards compatible in that sense. But yeah, it's a good point. I have to. Yeah, that's what I think it's more or less that way, but I'm not 100% sure. Because I haven't really seen too much issues on SRT compatibility in the wild. I don't know, have you? Okay. Yeah. Okay. Let's go on. Okay, so I just want to give a quick example. Just that, okay, we have an encoder, and we want to receive that feed in let's say, VLC, for example. So I'll do that now. Basically, I know that I have my encoder. I can reach it on this address. So then I'll just insert the URL. So I give it the URL or IP, and then, okay, which port am I using? So. Yeah. Oh, actually, this is the wrong URL. Oh. Yes. Yeah, I should have checked this, but nope. And let me. So this is my encoder, okay, and I am using port 10,100, yes. Okay, so now I'm receiving the feed from my home encoder. It's going through my router. My router has port 10,100. It's port forwarded, so that's going to my encoder directly. So, and here we can see that the connection is active. I can see some statistics here already. For example, the RTT value, which is 36, and I'm using a latency value of 120. So okay, that's 4 times. So I think that's okay. On this, yeah, let me stop this. Yeah, so then we can do the same example, but with using a Play Pro here. So I'll create a link, and actually some people had the Play Pro, so I want them to scan it. So let's see who is able to. So I'll just create a QR code. So is someone able to scan it? Okay, someone is viewing it, but Makito is only accepting a single connection. No, that's good. So also, yeah, really simple to share stuff, and yeah, Play Pro is nice on that. I'll also show you the ISR player. Actually, yeah, but yeah, you're still viewing it. Yeah, okay, it's okay. So let's move on. Good. Yeah, so that was just a simple example of how to use SRT on that. I have few more advanced topics with SRT. So that's basically, SRT also supports path redundancy. So you are able to send the same SRT feed over multiple internet links to the receiver. And then on the receive side, it's basically taking the packets into the same buffer. So it's basically packet level failover, what you have. And this is already also included in the SRT protocol. So I would say it's really similar to 2022-7, but it's different because it's an SRT implementation. But this is supported on Haivision equipment in Makito's SRT gateways, but we haven't really seen too much adoption outside of Haivision for this feature, unfortunately. Yeah, another feature that is interesting is stream ID. So basically it's that we are able to we are able to receive multiple SRT feeds over a single UDP port. So I would say that it's comparable with, in RTMP you have stream key, that you're able to add a tag that, okay, I identify my feed. This is stream 1, this is stream 2, whatever, like this. So this is how the cloud providers are actually using it. If you need to stream SRT to YouTube, you have to use a stream ID. They don't want to open a zillion different UDP ports to all the different users. Dolby is using it the same way, and a bunch of others as well. Good. So, a few words about the latency differences that we have with RTMP versus SRT. So, like previously, I showed you the map. So here are some examples that the longer the distance or the destination, with RTMP, the latency, it really becomes it becomes big. Like between Germany and Sydney, okay, with SRT, we are able to get to, what's this, 1.7 seconds, something like that with the Makito. With VLC, it's a bit longer. But with an RTMP link, this is close to 10 seconds. So it's quite a big difference. And so then, similar values, okay, Germany to US, US East, EU, yeah. So RTMP is fine if the distance is not too big, I would say, in that sense. And here is a similar comparison. Trying to send an RTMP feed to Australia, okay, you might be able to do it with 2 megabits, but if it gets higher, it's already failing. So yeah, and then, so this is the conclusion basically, that with sending feeds over public internet, it's unmanaged. We are not able to control the network. There's bound to be packet loss there as well. So with SRT, we have a mechanism to recover from those packet losses and reconstruct the feed, like I showed you previously there. So, and the end result is that, okay, we have a low latency and we have a good image quality that we are able to use in broadcast applications. So good. Let's see. Okay, few more. Then the actual. This is just a slide on SRT adoption. So to show some milestones. Like in 2017, VLC and FFmpeg already added support for that. In 2019, we got the ME. Yay! And then 2023, YouTube added SRT ingest support into their platform. It's still a bit of it's not publicly available. So the channels that want to use it, they still need to request it from Google or Google YouTube to have it enabled. It's a nice, really nice addition as well. And then, oops. Again, a wall of logos. This is just a small snapshots of companies supporting SRT in their workflows. And what we are seeing more and more is cloud production platforms that you are able to ingest SRT and you are able to do your production in a cloud. Okay, GVAMP, ROS, Avid, others. Yeah. Okay. So SRT is open source. Anyone can use it. Anyone can contribute to it. I can show you the website. So here it is. So the latest version we have is 1.5.4. And yeah, if you want to go to the, okay, some examples. Yeah, it's all here. The same way the SRT Alliance is here. And SRT Alliance also has, okay, here, yeah, we have the resources, everything. They also have a really nice Slack channel here. So, and there's our SRT developers hang around here, and usually there's yeah, lots of questions. Okay, how do I do this? How do I do that? I'm facing this and this issue. So yeah, there's only 2,500 people here, so I'm sure there's someone that has faced a similar issue if you want to go that route as well. So yeah, just to show you that. Okay. So I would say that SRT has become the de facto broadcasting standard over public networks. And it matches all of the criteria and the needs that we need on a protocol. Compared to satellite managed networks, it's a huge cost saving. Yeah, using later on I have some actual examples, and then I can share some figures as well. But yeah, so we see it as a big cost saving. So, and yeah, it's anyone can use it. Software, hardware, doesn't matter, or implement your own solution. It's yeah. And it's not tied into a single vendor. It's not, of course, Haivision was one of the inventors of SRT, but now it's open source. There's lots of different companies, lots of different people that are contributing it. It's developing further as well. And yeah, it's a big ecosystem, and the bigger it is, the better it becomes. A step back on the broadcast report we've been running. So now we are finally seeing that SRT is becoming the dominant protocol. I think 2 years ago it was still RTMP was the number one. That what transport protocol is the most used. Now we are seeing that SRT is the most popular. Of course, there are other protocols doing the same thing, Zixi, RIST, but they haven't really seen that type of adoption. And I would say that's also that, okay, they are not open sourced. It's basically what Peter Mag started with, that, okay, you have your own little protocol, it's supported in your products, but it doesn't get the industry adoption that you need on that. So, questions on the SRT side? Everything is crystal clear? Yes?
I have a question.
Huh?
You've been talking about the minimum value of the latency.
Yeah.
What about the
Maximum. So at least on Haivision products, our maximum is 8 seconds that you can use. And also, it's, I didn't explain that. Hold on, let me find the slide.
I give you some example.
Uh-huh.
When we have some issue with the stream provider,
Yeah.
they said, okay, the issue is because you have too high latency buffer.
Really? Okay.
I don't agree with that. It's strange for me. From my point of view, it's only how big buffer I have,
Yes.
how much data I can store there,
Yeah.
and it gives me more time to request the packets.
Yeah.
Of course, I couldn't request packet which is not in the buffer of the encoder.
I think it's that because both sides, they need to maintain the same size of the buffer. And was it over 8 seconds or how?
No, it was like half second. Yeah.
Okay, that sounds weird. Yeah. So I would say, because in SRT, it's you have the both sides. You have the caller, you have the listener. And each side can set independently the latency value in that. But when they do the handshake, the SRT handshake, then basically it's whichever side has the higher value that is picked. Yeah, but that's weird. But yeah, so that's the principle. For me, it sounds really strange that already with such a low latency value, I don't understand. Yeah.
Me too.
Yeah.
It was just we have been looking for where the issue is. So
Yeah.
it was easy for the provider to say, okay, issue is because of that.
Okay. Yeah. Really strange. Yeah. So like with our products, with Makitos especially, there we have a hard limit on the 8 seconds of buffer. It's just that, okay, it's a limited number of memory that we have on the device, and okay, it was decided that, okay, that's where we set it. I know some vendors are using that you can go even further with the buffer value, even like 10 seconds or something. Of course, it's nice, but then it's okay. Is it real-time broadcasting anymore? So, yeah. But because in the end, of course, you have to translate the latency and the time figures into actual kilobytes and megabytes. Yeah, and then you have physical limitations on that. But yeah, no, interesting point. Yeah. Anyone else? Yeah.
I'm very sorry, but I have to confirm I have experienced exactly the same thing.
Wow.
Because the buffer value is usually
Yes.
And it helps very often, and I fully understand why it works.
Mm-hmm.
But I experienced the same as Tomáš said. The other side recommended us to decrease value from, let's say, 1 second to half a second.
Hmm.
It helped, and I don't understand why.
Was it with our equipment sending or some other? Or?
It's a standard contribution within Europe. I think.
Okay, okay.
I don't understand it.
That's yeah. I mean, yeah. I don't understand it either. That's yeah, something to investigate maybe to figure out.
There's some limitation of bandwidth.
No.
Okay. Hmm. Yeah. There are different things.
On our side.
Yeah. Okay. Maybe. Yeah. Okay. Then I'd like to talk a few words about SST as well. So you probably remember Avivest and the bonded backpacks. So a few years ago, Haivision bought Avivest. And with that, we got a really powerful tool into our toolbox. Like with SRT, it's perfect for wired networks, but for mobile contribution, where you need bonding, SRT is not the best, because in SRT there is no bonding. There is, like I showed, you are able to do path redundancy, but that's not bonding. That's basically duplicating your outgoing feeds over different internet links. With SST, then it's an actual bonding. And so the first guy, that was Peter Mark here, and then the second guy here is Ronan. He used to be the CTO of Avivest. Now he is head of engineering for all of Haivision. So he's now actually combining these two worlds in our products. So, so what does SST do? So it's able to combine basically any IP-based link and use that for bonding. So either it's Wi-Fi, if it's cellular, starting from 3G, 4G, 5G, whatever other IP links, satellite, and also Starlink. So you're able to combine all of them and create a big enough pipe to do your transmission. So, yeah. So, again, we come to the issue of error correction, how we are able to send, how we are able to get good image quality out of unmanaged networks in strange locations. So yeah, usually this is for field contribution, that we are able to contribute content into the studio and then distribute it. SST, another difference with SRT is that SST is bidirectional, so it's also able to send data back to the transmitter. So, and then you can have different applications there. That, of course, the first one, we are sending a video feed, but the same way we can send files, we can transport IP data, intercom, some video returns. So everything goes inside the SSD tunnel, so to speak, here. Well, this is the same IP data, so you can have a remote control of devices over this tunnel as well. It has similar features as SRT. So it has AIACU, but on top of that, it's also able to use FEC. And then, of course, it's able to aggregate whatever networks it can, and it can then also tell to the actual encoder that, okay, this is the total bandwidth we have. We need to match our video encoding into this. So, yeah. And let me see. So just on a high principle. So first, when we receive all of our packets, they come on over various different networks. So first we need to reorder the packets inside our, our receive buffer, the same as with SRT. Then we need to check that, okay, are we missing anything? Do we need to re-request some packets? And then also, do we need to reconstruct some packets with FEC? So there's multiple different tools that we are then able to use to make the transmission as robust and high quality as we can. The other way, I forgot. Okay, yeah. The other way is the multi-camera synchronization. So with the SSD, it's the receiver that is basically giving the clock to the transmitters, that we are able to have all of our transmitters frame aligned. So if it's the same event, we want to have them. We need to have our feeds in sync. In SRT, this is done a bit differently. I'll have an example later on, but in SRT, we are using NTP timestamping. That the encoder is taking the NTP clock. It uses that to timestamp the outgoing video frames that then the decoder or the receiver is able to use to realign all of our video feeds. So we have that support like we've done our Makito decoders, but that's also supported quite a lot in cloud production environments. So it's basically we take the NTP timecode and then we timestamp it as SEI timecode as part of the feed. It's, yeah. Okay, and another big feature with SSD is that it's able to dynamically adapt to the network conditions, both on the bit rate and then also on the resolution. And yeah, and then this is the end result. So as a conclusion, so for wired networks we have SRT. And then for mobile networks, we have an SSD protocol. So I'd like to do another demo, again with the Play Pro. So I want to do it this way, that someone from the audience is sending a feed to my gateway, and then everyone else is able to pick up that feed from that gateway. So let me set it up, and then it's more interesting. So let me see. Yeah, let's use yeah, let me use this one. So I'll make a new route. So, does someone want to be the contributor? Oh, oh, sorry, I'm not seeing the... Yeah, now you see it. Someone got it? I'll make it bigger. Sorry. My mistake. Yeah. Yeah. Okay. Yeah. I had it. I had the wrong side. Yes. This one. Let's set. Yeah. 2 megabits. I think it's good. Full HD. Yeah. H.265. Good. I'll increase the latency to 250, just in case. Okay, let's try again. Oh, sorry. Okay, so we have connected 0 bit rate. Oh, that's not good. Let me see if I can. It's not. Okay, can someone else try? Yes. Okay, yeah, we have something running. That's good. Yeah, so now we can make another QR code that then you are able to play this. Yeah, so let me see. Let me try on mine. Now I'm seeing it. And now we can see that, oh, we have a good amount of clients here. So who is streaming? Okay. So, just to demonstrate in action what we are able to do with SRT and with an SRT gateway here. So I can actually show you a bit more on the statistics here. Let me. So here, for example, we see the sender, the camera, that okay, we are getting some 2 point something megabits that is coming in. Let's see, where's the RTT value? Ah, yeah. So our RTT, so basically it's RTT between the phone and my SRT gateway that is in AWS in Frankfurt. That's 30 milliseconds. And we are using a latency figure of 250 milliseconds, which is already, we could go lower, so we could go now to something like 90 or 120. So this is good. But each time we are having the SRT, there's like here, let me show you. Like here, we have first SRT connection from the camera here to the gateway, and then we have second SRT connection from the gateway to all of your phones. So in the end, it's double the latency. It's first the 250 milliseconds plus the actual video encoding latency. Then it's all the receive side and its SRT latency. So using this type of relay, you have to, you will have an additional latency in the chain. But anyway, it'll be lower compared to RTMP or something. So yeah. So this was a nice little example, and like here, I can also show you I can pick one client that, let's see, yeah, that's using 125. Yeah. So these statistics are the tools that you can use to actually start diagnosing what's going on with my SRT link. Am I seeing lots of dropped packets? Is the RTT all over the place? Is there lots of jitter? But in the end, the tool what you have is, okay, I increase or I decrease my latency figure. Yeah, and basically you can see these statistics, like with our products, you see the same statistics on the encoder, and you see the same statistics on the decoder. It shows the same. And you can make changes on both sides independently. So if on the receive side you increase the latency, it re-establishes the connection and then uses that. So yeah, that's it. You have any questions? No. It's just a relay. Yeah, we have other products that can also, record. Like StreamHub can record incoming feeds. Then there's the Haivision media platform. But yeah, a gateway in itself, it's really simple. It's just it takes stuff in. It's able to de-encapsulate them, re-encapsulate them, and send them out. So it's actually a really simple product. So like here I can show you. I have my input. These are just the protocols. So we have SRT, or it can also be UDP, RDP, and also RTMP. And then I can have a bunch of different outputs with different formats. And then, of course, in a distribution workflow, I could have different routes. I could use different encryption keys. I can start and stop them independently. So if I need to distribute to different customers, so yeah.
Does the gateway have like reporting for its own latency? Because we have latency for the incoming stream and for the outgoing stream. But also it should have at least a large buffer size available.
Yeah.
Buffer for the gateway itself. So does it report like end-to-end latency?
No, it doesn't report it that way. That's a good question.
Because there has to be some like transition memory from one stream to another, and also
yes.
at least the biggest buffer size we use for the gateway. So
yes, yeah. So that's a good. I don't have an answer to that. but what I've noticed is that it doesn't add much on top of what you have already configured as your incoming latency and your outgoing latency. So if you calculate those and then you calculate what is my encoding latency and my decoding latency, okay, you get to the end-to-end. Actually, I have some Excel files somewhere. I can. I've done some end-to-end calculations as well. I can look it up. Yeah. Good. So it is 11 o'clock. So is it time for a break? Good. Well, thank you.
Já bych poděkoval Mihkelovi za tuto první část. Teďka bude následovat zhruba půlhodinová přestávka, coffee break, takže se můžete občerstvit tady před sálem a potom budeme pokračovat s konkrétními user casey, kde nám Mihkel vysvětlí nasazení a nějaké konkrétní případy a případy remote production v Evropě, kde se tato technologie od Haivisionu používá. Díky za pozornost.